Hey guys, hey folks, this is Robert with RetroBasic.com. Today we're doing a little bit different. It's a training, and it'll cover how to make an interesting graphical on the screen. It is my computer was doing something silly. It is a very unique trick with the screen and characters and how they're put on screen. When we run it in Retro Basic today, it's not going to have color. That's going to require a trick, a little tricky trick. So I'm going to go ahead and the first step is I'm just going to show you the basic program itself and show you how it functions. And you can always add this into any program you're making, whether it's Retro Basic, RetroBasic.com, guys, or just a Commodore 64 in general. So let's run it. All right, there it is. It was from a book from 1980 on graphical tricky tricks. What it does first is CR is going to be the subroutine called to reset X and Y in the system. You're kind of like a locate XY. CY equals CR plus 10. So that's the Y position for the subroutine to grab onto. It's 49162, and CX is 49163. And then we'll skip down here to oh yeah. The reason I'm showing this here is this is where it's going to take the byte data out of data and put it into 49152 to 49152 plus 9. It reads the A, pokes A into the position, and I'll show you the whole thing about that program too. It's got some tricky tricks, very tricky. And there is the data right there. It looks confusing. Most subroutines you find in a basic program end with 96, or the RTS, return to system. And then this other data down here is character data that's going to be read into an array, and then it's going to pokey print to the screen, and it's a pretty tricky trick. Here's a 4t equals 0 to 4, 4u equals 0 to 9. This is just reading in the M string data. It reads it. And then we have M string T, 0 to 4, equals M string T plus a character string K, which is read from the data. You got a next, and then we're going to poke 9 into 53200-280. That's just background and border colors. We clear the screen in 113. Printing character string 5, I don't even know what it does. It's got to do something. Maybe we'll look at it at that next time. For Y equals 0 to 8, step 2, LI equals a random number from 1 to 5, or so and such. LI equals IY. If that happens, we go back to 130. And then IY is set to LI. RI equals LI. If LI greater than 2, then RI equals 7 minus LI. Now that's just some tricky tricks to make a graphic. These are tricky tricks with numbers. And like I said, a lot of the stuff going on line 150, I don't know. Let's go on. For X equals 0 to Y, step 2. Now this is the main loop. XT and YT are going to be calculated based on how you want the screen to look, and it starts out as a little core, and it goes out like this in 4 steps. You'll see when it runs. So I'm just showing out all the numbers here. You got 2 loops where it looks at 10, and then it upgrades that to 20, and then we have X and Y with minus 10, and then minusing Y, and then plus Y. All of it has a go sub 800, which we get to in a second. And then we're going to end out with the next. We have a time loop in 210, which you can shorten. Now 800 is where it calls that system function. It's going to poke CX and CY into their locations, calls system 49152, and then we return from 800 back to the I call them the 4 print statements because they set the X and Y and they print. All very neat. We have the go sub to the tricky trick subroutine, and then the print. That's about it for the program. There's a little bit of data at the bottom. I should show you that though. Hold on a second. We'll scroll down here. Oh, well, we didn't scroll down. This is 49152 in a nutshell, and it's very simple, but it's going to cause some routines in machine code, which we'll show you. We have C000 hex, clear carry. That's important later. Then we have a load X, C00A, which is 49162 exactly. Load Y, C00B. That's 49153. 49163 exactly. Now all it does is jump to FFF0, a kernel routine that does some trick with the X and Y numbers. And we'll look at that in a second. This kernel routine document is out there on the internet. When it loads up, it's got everything. It shows you all the subroutine functions in the kernel, all the basic, and how they interrelate. Everything is commented. So let's put that on the screen. Run it. This is the magic. What we have is a read/set XY cursor position function called at FFF0. The kernel routine is when it's called with the carry flag set, it will load the current position of the cursor into the screen, or on the screen, and into the X and Y registers. That's the key. And we'll show you how it does that. X is is a column number where the cursor is located, and Y is the row number where the cursor is located. A call with carry bit clear moves the cursor to the position determined by the X and Y register. And that would then have a jump command. So all this does is really jump to this E50A routine. So let's run it. We'll shift over to that. It'll take a second. Let me move up there. Okay, hold on. It's down here somewhere. Down a little more. Yeah. E55. I think we're almost there. E518. There we go. Okay. Found it. It's a big bunch of code, a bunch of tricky code. Okay. Read set the XY cursor position E50A. Branch. If carry set. Now that takes us to another subfunction. And since we cleared the carry, we wouldn't be going there. So we'll go on through this loop. And this gets confused. Later it gets real confusing. But hold on, it's not too bad. This is the loop where it would go to, which we won't go to. Let's go back to here. First we are going to store the cursor row position. Okay, second file. Now we're going through the 050A. We loaded X with a D6. It's all very clean code. The rest of this is just going to get the actual row. Here's the actual stuff that's happening. There's going to be a loop and a return. Get the start of well, the good news here is a lot of this kernel stuff is we don't understand much of it. I'm sure 8-bit show and tell, if he looked at this code, he would say, oh yeah, that's it's no big deal. But the tricky tricks are so tricky that we don't understand some of the kernel stuff. I'll admit it. And then this BPL is a just an overflow. We have a JSR, if it were to go that route, to fetch a screen address. So if it this code here gets the actual cursor of the position if it didn't know it in the first place. So it's more tricky than we need to look at. It was where the program would go, I think, if you didn't provide it with the X and Y up front. And the return there, jump EA24, is I believe it's a jump just straight back into BASIC. It says calculate the pointer to color RAM and return. EA23 will take you straight back into... I've seen EA2 something take you straight into... Okay, let's get serious here. This is getting out of control. Okay, we're going to demonstrate it here. Run it. As you see, this is pretty colorful. This is running in Retro BASIC. It's not... Commodore 64. This is just straight Retro BASIC, and this is the code before we modified it at all. And it's pretty cool. It's pretty synchronous. Now what we're going to do is take the code in the BASIC and carefully go in and change a couple numbers and show you what happens with the screen. And you saw the screen. It's pretty. But we're going to change a 5 to a 9, and then I'll poke in... what should I put? Yeah, let's put 147 where these 157s were. Run it. And see, it changes the whole structure of the graphics on the screen. It's still flashy. And it's got a couple glitches, but it's still, if you were in a game and you were taking if you were going through a dimension, you know, or through a portal, you know, and that's why I thought it looked tricky. I'm going to use it in one of the games somewhere, because you just load it and run it, and you know. Okay, we got another test we're going to do here. The previous changes are still in place, so we still have our 9, and we're trying to get to the first row here. It's kind of hard. We'll edit. Okay, we're going in 8. Yeah, we'll leave those there. Okay, and then we got, if I can get right on it, put the 8 back, change up, back over to 5, we'll make it 5-8 just to be interesting. Okay, let's see what that does. It's going to look neat again. This routine looks neat every time. This one's kind of like, it's got some square shapes running around in it. Again, it looks cool, and you can speed this up. What I didn't try was changing that timer loop to 1 to 600. Here we go. We're going to change some more stuff. I didn't even think about changing the time loop, which is it on the screen? Yeah, where's that time loop? Yeah, but we'll go in. Let me make the changes here. Oh boy, 129. That's a big change. 1522, yeah. Now, should I change something on the second line? Yeah, might as well. Well, let's make that 7 again. And should we make this 2? Okay. and I'm going to, run it. And see, it just puts different shapes on the screen all over the place. It is fancy. It is neat. And, I don't know, should I do one more of these, or I want to keep this short. So, back to the beginning there. Okay. Well, I hope you guys like that. As you can see, if you were to change any number of those numbers in the data, you could make anything happen. I am going to place this routine in some projects where you're going from one phase to another. You're going to have it be a level change, and it would be cool. No way to doubt it. It would be very cool. So you got that going for you, which is nice. That's nice. And so I guess I'll end it here. I may have an issue with audio because the recorder is doing something very strange. We'll see. When I play it back, it looks like it's nothing but looks like it's all too loud. But, yeah, we'll see. I don't know why it's doing what it's doing. So, hey, this is Robert with RetroBasic.com. We'll catch you later. You guys have a great day.